First, we have to find the domain of our function. We see that our denominator will be equals 0 for x equals 0. So the domain of our function y is all real numbers excluded 0. So now we have to check the limit of our function as x approaches negative infinity. First, we have x minus 1 over x squared. This is equal. We can rewrite our function limit as x approaches negative infinity, and we have x over x squared minus 1 over x squared. This is equal. We can reduce square with x. So we have 1 in numerator. So limit as x approaches negative infinity of, we have 1 over x minus 1 over x squared. Because the numerator is going to negative infinity, so 1 over negative infinity is going to 0. 1 over positive infinity, very large number, going to 0. So our limit is equal 0. It means we have horizontal asymptote on the left side, y equals 0. Now we have to check the limit as x approaches positive infinity of x minus 1 over x squared. We have to do the same calculation. So we have limit as x approaches positive infinity, and we have 1 over x minus 1 over x squared. So this is equal 0 because 1 over positive very large number is going to 0, and 1 over positive very large number to square is still very large number. So this is going to 0 and this is going to 0. So we have limit as x approaches positive infinity equals 0. So we have horizontal asymptote on the right side. So we can write that we have both sides asymptote y equals 0. This horizontal asymptote. Now we have to check the left and right limit as x approaches 0. So we have limit as x approaches 0 from the left of our function is x minus 1 over x squared. This is equal. Like always when we have left or right limits, I always draw the graph of function which is in denominator. So we have function x squared. The graph is parabola, open up because we have positive coefficient before x squared. And we see when we are going to 0 from the left side, the values are positive because they are above x-axis. And very small, we're going down. So we have very small number positive. And numerator, we have 0 minus 1 is negative number. Negative over positive give us negative infinity. So we have vertical asymptote on the left side, x equals 0. Side, so I can write left L, and we have to check now limit as x approaches 0 from right of x minus 1 over x squared. We can use the same graph. When we are going to 0 from the right side, the values are positive because they are above x-axis, and very small, we're going down, very close to 0. So we have positive number in denominator, very small. In numerator, we have 0 minus 1 is negative. Negative over positive give us negative infinity. So we have vertical asymptote x equals 0 on the right side. So we can write, we have x equals 0 vertical asymptote on both sides. Now we have to check if we have slant asymptote. Because the degree of numerator is smaller than the degree of denominator, we don't have slant asymptote. We have slant asymptote only when the degree of numerator is 1 greater than the degree of denominator. So we can write non-slant asymptote. This is my solution.